Hi guys, I just wanted to make a quick video to go over the practice problems that I put in the PowerPoint for this week. Again, our major topic for this week was calculating percentiles when using z-scores. So again, z-scores are going to estimate, right, a percentile for a given sample or a population on the assumption that we have a normal distribution. Okay. The other type of calculations that we've used to calculate or to get percentiles are from our frequency distributions, right? And that's when we use our cumulative frequencies, and then the big complicated group frequency distribution, right? We use all of that information to find exact percentiles for individuals within a given sample. So just to reiterate, z-scores are going to estimate a percentiles for a sample or a population, given that we have a normal distribution, or assuming we have a normal distribution, right? And then our distribution or frequency distribution calculations are going to give us exact percentiles for a given sample, okay? So we have this slide here. You guys don't have these red numbers, okay? So that's kind of the whole part of this exercise, is to have you manipulate the z-score equation, and then it also will help to give you some practice on using your z-score table, okay? So our first little set here, right, is we have raw scores or values, right, and we are given a mean and a standard deviation, okay, and the first one is given for you, right? Let's say we calculated the z-score and we got negative 1.86, okay. Once you get a z-score, this is again equivalent to the number of standard deviations away from the mean. So we could say negative 1.86 z-scores or negative 1.86 standard deviations from the mean. This is indicating that we've almost gone 2 standard deviations below the mean, right? So if we have a negative z-score, we're going to use the negative z table. And the way that we look up this information is we go down, right, on this first column, we find negative 1.8, and then we'll go all the way across until we find the 0.6 area, or 0.06, sorry. Okay, so this first column matched with this column of 0.06, right, should give us the probability that exists for a given z-score of negative 1.86. And when we say probability, again, this means that we're listing a particular value from the z-table as is, right? So a probability is going to be a value between 0 and 1. If we're asking for a percentile or a percentage, we have to multiply this value in the chart by 100 to get our actual percentile. So that's what we did with this red value here, right? You can see it's 3.14%. Okay. In this next one, we have a value of 16. Now, I gave you guys the percentile, which is 22.06. So just knowing that our percentile is between 0 and 50, we know we're going to have a negative z-score, negative standard deviation, okay? So granted, you could go through this and look, right, throughout the table until you found 0.2206, or we can work with our calculation, right, which again is going to be our raw score minus the mean, right, divided by the standard deviation. So in this case, right, z is going to equal a raw score of 16 minus 21 divided by our standard deviation of 6.46. Okay, remember, order of operations, you want to carry out this top part first and then divide by the denominator. And if this is done correctly, you should get negative 0.77. Okay, so a lot of this is just like if you were given some raw score and a mean and a standard deviation, right? You could just completely delete all of these values from this table and then see if you get the same values that I have filled in here. Okay, but that's kind of how we're operating, right? So we end up finding a z-score, and then we can say the estimated percentile that's associated with a given value. So in this case, we're working with negative 7.7. So 0, 1, 2, 3, 4, 5, 6, 7, right? And we get 0.2206, or we get 22.06% if we're converting, right? And the thing is to remember, I'll use this one as an example, right? If you have, or we'll make sense of this using our distribution. So if I gave you the mean of a sample, which we're saying is 21, right? And then I gave you the standard deviation, which is I might lie right there. It's 6.46, my bad. Okay, so a standard deviation of 6.46. You should be able to create your own distribution off of just this information, okay? And there's two ways you can do this. One way would be, we know the mean always exists in the middle, so one way we could do it in the units of the given measurement that we've taken, right? So 21 would be in the middle, and then since we have a decimal, I'll do calculator, right? Standard deviation is just going upwards, right? So we should have up to, extend that a little bit more, right? 3 standard deviations going up and 3 standard deviations going down. We don't usually go past that point because if you remember the empirical rule, almost 100% of our data is between 3 standard deviations, okay? So this is way 1 using our units, and then I'll show you method number 2, and either of these would be acceptable, right? You would either say this is the mean, or 21, or you could say this is technically 0 if this is in terms of standard deviations, right? And then going this direction, we should have +1 standard deviations, +2, +3, right? Going this direction, we'll have -1, -2, -3, right? So we can kind of use this format to calculate how it would translate into units, okay? So if we know our mean is 21, that's our starting point in the middle, right? If we're doing +1 standard deviations, you can think of it as 1 times whatever the standard deviation is. So basically we're just doing 21 plus 6.46, right? And then we can start filling in, this is 27.46 plus 6.46, right? Or 2 times the standard deviation, right? And then we're at 33.92 plus 6.46, and we're at 40.38, okay? So this is in the positive direction, right? So again, this lines up with +1, +2, +3 standard deviations, okay? If we start from the middle again and we just subtract 6.46, we'll get 14.54 minus another 6.56 will give us 8.08, minus another 6.46 will give us 1.62, okay? and these are equivalent with -1, -2, and -3. Okay, so when we look at the percentile that we get, right, or just based purely off of the z-score, let's say, for a different example, let's look at 28, right, or a raw score of 28. So if we look somewhere on this chart, right, 28 would land somewhere in between 1 and 2, right? If we just go off 27.46, right, maybe halfway is 30. So you kind of gauge, we're going to be a little bit to the left of that, right? And we could say our raw score probably exists here, and our raw score we're saying is 28, right? When we look up our percentile, okay, it's going to be, again, the area to the left, okay? So that's what we're looking for when we calculate our percentiles using z-scores, okay? And again, we emphasize this in the lecture, but if you're looking for the probability that somebody scores better than 28, or whatever the units of measurement that we're dealing with, right, you would take 1 minus the probability here, right, or 100 minus the percentile here, and that gives you the area left over, right? But you can see, right, where this is located just based off of our units of measurement. If we look at the z-score for this particular example, right, it ends up being 1.08. So if we draw it on this one, right, 1.08 is relatively, or it should be relatively in the same spot, given that we have a normal distribution. And again, the probability that we get is going to be this shaded area, right? So when you're drawing out your distribution with your raw scores and mean and standard deviation stuff, you can do it 2 different ways, right? One, using the actual units of measurement that you've collected, or one using just general standard deviation values, and then you plot your raw score based on the z-score that belongs with that raw score, okay? But in either case, right, this probability here is going to be the same area. And in our case, it's going to be 85.99%, right? So as a probability, we would put 0.8599 or 85.99%, okay? So hopefully that helps make a little bit more sense of how all of this works together. Again, if you guys have any questions, please feel free to let me know, okay?